they were done by this amateurish guy in Israel who's... Oh, we're good? Yeah.
We were just talking about the pre-conversations that go with podcast recordings and live streams. Hi, I'm here with Guy Podjarny, CEO of Snyk. How are you, Guy?
Doing well, thanks. How are you?
Great. We're here at the Cloud Foundry Summit, and I think the last time we spoke was at the Cloud Foundry Summit in Basel.
Possibly.
Yeah. The topic really for us today is exploring the dual popularity of Kubernetes and serverless architectures. I just am interested in this topic, and I know that the Snyk story is interesting. I like how it's the philosophy behind it, and how you're trying to build security into like that whole developer process, right? Not as an afterthought, which is a growing trend that we see, especially with the advent of Kubernetes architecture in microservices environments, right?
Yeah, definitely.
So, I'm trying to kind of like marry this concept of what you guys do with this concept of this dual popularity that we're seeing. And it seems to me that one of the problems that we have with serverless architectures is there may be just a little bit of code, but there's all these dependencies that come with it. And I'm curious on, how you view this.
Yeah, I think it definitely is, a complicated world, and oftentimes from all of this ecosystem and how they interact, a lot of it is just almost like a level of abstraction. When you are talking about bare metal, we had just machines that you manage. You go up to VMs. Containers are sort of a more agile entity of it. Serverless, further platform as a service somewhere in between, or sort of somewhere in that mix. And I think in all of those components, there's this level of different components that you do or do not need to manage, and that's kind of a part of the core differences between them. And you choose your spot in the stack. When you're talking about you need to manage, who's this mythical you? It really comes down to the developer, to the owner of the application that needs to provide it. The more you need to provide, the more of a hassle it is. And yet, the sort of the less you manage, the more dependencies you have. You are building wonderful things with minimal effort, but you're doing that by relying on other dependencies that provide that functionality. At times, the platform, and at times these sort of libraries and components that you use around.
Right. So let's start from like backwards a little bit, from those libraries and components. And then, and step it back. What is it about those libraries and components now that we see now are changing?
Sure. So, first maybe define them a little bit. Yeah. So today, every application today, every system really has, one dependency that is sort of the underlying platform. This might be the containers or a Cloud Foundry itself or Lambda and in turn, it uses a lot of components, in increasing number of components. These are libraries. They range anywhere from a web server to a little component that converts a string to an integer. They can range in complexity, these libraries are effectively, they started off just being relatively. We used to only have larger libraries because of the effort involved in creating a library and sharing that library. It used to be, commercial or then open source, but heavy duty. As the process of creating a library became easier and easier, best kind of manifested in the world of JavaScript with NPM, there's this explosion of libraries that are really like the community reusing code. It's like Wikipedia. People create components, create libraries, and then the world gets to benefit from them. So because they're so compelling, because they're so valuable, businesses and other open source projects embrace them, by the bucket load, because who wants to reinvent the wheel? You want to build your own core component and then use these libraries. And at times it gets to a place where you think that it's almost a little excessive. So if there's a good example in a serverless JavaScript function, which has 19 lines of code. It's one of the sort of examples. Fetches a file from S3, stores it from the internet and stores it into S3. It uses 19 lines of code, 2 dependencies, which in turn pull in 19 dependencies, which in total have 190,000 lines of code. So this 19 lines of code is really this drop in the bucket. We just did this same exercise with a Spring Boot function. Again, in the container and microservices world, 80 lines of code leads to 700,000 lines of code in this sort of combined. And that's not a bad thing. It's a good thing because you can create 700,000 lines of code worth of value by only writing 80. But it also implies you have to create new methodologies and new concepts on how do you manage this monstrosity of a dependency graph, which if I kind of ramble on a bit here, so this is kind of current reality, right? We're using these libraries. The majority of our code is open source. It's these libraries that you use, and now we need to sort of understand how do we manage them. To me, that really comes down to this question of whether these libraries are infrastructure or are they code. It almost kind of feels in this circle. Like you think of serverless and you say, well, serverless is not serverless. No, of course.
Right.
There are servers behind the scenes. But it is a server managementless, right? You're not managing the servers.
It's a resource.
Yeah, except you have these libraries that you pulled in from the internet that you need to patch, just like you patched your servers. You have permission management around what does every function get to access. And you need to manage that just like you needed to manage what does the server get to access.
Right.
And you need to manage a lot of these infrastructure-esque components. And we get into this slightly mixed up world today that has these like sprinkles of infrastructure. That's my kind of favorite term today for it, that are just sort of strewn throughout our apps. And they look like code, but they behave like infrastructure.
There's sprinkles of infrastructure that... And how do you identify these sprinkles of infrastructure?
I think it's around kind of drawing lines. So, again, kind of there's a bit of a meta here, but so you have an application and you have written code.
Right.
What is the app? Minimal description is it's the code you wrote. It's like you wrote code and then you decorated it with libraries and with a container and the likes, and you moved it on its way. And next tier is it's not the operating system. You've got I've got my code and it uses these libraries. That's the boundary of my app, and that in turn gets wrapped up in a container. It gets shipped up, and then you can take it a step further and you can say the container is the app. The container with this operating system. That's the blob that I move around and that I operate. I think of it this way. You can even take it a step further and you can say, well, that's a microservice, and really the app is the sort of broader perimeter of a sequence of like a mesh, of like an Istio, or like just a chunk of microservices. Every one of these platforms defines it a little bit different. Mm-hmm. So when you talk about like Cloud Foundry versus, we talk about this dual nature and in Cloud Foundry and serverless, in Cloud Foundry, platform as a service, the boundary is that middle one. It's the code plus the libraries, the dependencies that it pulls in, but the container is out of bounds. In containers, in Kubernetes land, the container is now a part of the app, and there's all working groups defining the application definition as part of the containers in Kubernetes. And even serverless is kind of where Cloud Foundry sits. It's kind of like in the PaaS world, except it removes the sort of server capacity management. So in some areas we're really good at drawing the lines. It's like just these definitions. Kind of my world in securing it is you have these libraries. The libraries, no matter where you drew the line here, and the one I just described, still get factored in as the app, except they behave like infrastructure. They are widely used components, oftentimes vulnerable, need to be updated and fetched from outside. It's code you do not know. So in my view, of the world, we need to start thinking about those and drawing the lines a little bit better, drawing the lines a little bit finer, creating a lighter weight definition of the app, and say, I push my code. These dependencies, they require an infrastructure management layer of functionality that says which dependencies are in here, are they insecure, you need to patch them up, are they stale? There's other questions you want to do about them, and then start evolving practices around how we handle them.
It's a lot there.
Sorry, I went on for a bit.
No, it's fine. But we trace it back from the components and the libraries and any number of libraries and components that are available, and thinking about how those are factored in now into how developers are building their applications, and thinking of it also in terms of components. There's also then the aspect of what is actually infrastructure, right?
Yeah.
What is, is it that software that runs on the hardware, or is it the hardware itself with the software, right? And so in another world, you would then think of security almost like as a separate issue. So, so you'd had a separation. There was that line, right?
Yeah.
There was a line between software and hardware.
Yeah.
Now we're seeing that line fuzzy quite a bit.
Yeah, entirely. It's all like elastic software, infrastructure as code, elastic hardware, sorry, and infrastructure as code. I think security takes all of this mess and then adds a layer of complexity, because even within the world of infrastructure and code, of kind of infrastructure and app, security has always been this thing that happens outside. It's been a security team that was sort of small and outnumbered, and yet somehow stopped you from doing things. And they were the naysayers. They oftentimes still are. A part of the DevOps revolution, the whole continuous process. A lot of why we're here. It's all sort of this embracing a continuous pace, embracing kind of constant delivery, and this notion of stop here and I will audit goes away. It doesn't work that way anymore. Continuous is all about not stopping. So security requires some rethinking, requires changing its methodologies, changing its technologies to be able to get embedded. This trend is kind of the buzzword. You always see love and hate buzzwords, right? But the buzzword for it would be DevSecOps. And I sort of see, I do a lot of these like definition thinking. I think there's like 3 levels of DevSecOps. There's DevSecOps as in support secure DevOps technologies, container security, serverless security, just being able to run inside a container. There's DevSecOps as in secure DevOps methodologies. You are continuous. You want to embed security controllers into your pipeline. You are using microservices. Suddenly, you have to start tracking traffic that happens between the microservices if you're going to figure out what's happening. And then there's DevSecOps at the philosophy level, at the people level, that says the people that own security have to be the people that build the application, that have to flow from it. And in my mind, that's in DevOps you could see the same thing, right? Like DevOps, you can say DevOps is, I have a Jenkins instance, and I run it. You can say DevOps is, I use microservices. And you can say that DevOps is philosophical. My development team builds operable software, runs operable software, owns, cares a pager, on it. And security has yet, but is starting to go through this type of transformation, ranging from tools that kind of fit into each one of these levels of DevSecOps, and at the kind of to me the philosophical level is the most encompassing one, that says first you need development teams to embrace security, and then the methodologies and the technologies ensue, right? They make it possible.
So that's where is that a philosophy you share?
Absolutely. At Snyk, that's what we do. So we believe, first and foremost, we see ourselves as a developer tooling company that does security.
Right.
We're here at Cloud Foundry Summit. We go to Node Summit, to Serverless Conf.
Right.
We do that far more than to go to like RSA or Black Hat.
Right.
It's not about getting the security practitioner, who is important, but should play like a governance and a guidance role in this exercise. It's around getting developers to embrace security. And in the tooling, we kind of embrace that view. So we build tools that are loved by developers, and we have today, we have proof of it. We've got 120,000 developers. Our command line gets 350,000 downloads a month. We've got some brand name customers that are all kind of the wave of the future. It's either the Skyscanners and New Relics of the world that are I like to say that they are veterans in modern dev and new to security, or they're not new to security, but they're newer. And they evolve. They know that they want security tools that would be embraced by their development team who runs that modern dev, or it's these digital transformation entities that embrace, that are trying to. They're in companies that are veterans in security, but they're newer to modern dev, and they're trying to sort of adopt these technologies. Either way, all of them are aiming at the same spot, which is, embed security into the dev world, and that's really where we live. That's how we. That's what we live and breathe. Yeah.
Embed's an interesting word, and it connotes hardware in many ways.
In an extent,
embedded systems, right? It also, Also, what you say, kind of that, that kind of that middle space. You said, there's, if you're thinking about it, kind of in three sections, right? You're talking about the first level being the container, for example, right?
Yeah.
The second would be then, the
like a microservices.
the microservices. And then there's a philosophy. So, what philosophy do you bring then toward, like, topics we hear a lot now about observability?
So observability is it's actually a really, really good term. So I guess I'll kind of lay a bit of.
Actually,
it's I think so. Fundamentally, there's this adage of move fast and break things, right? You accept, you embrace,
right,
embed, whatever. The fact that when you're moving fast in an agile world, in DevOps world, then you don't always get things through the pipeline. Like sometimes you miss problems, and the way that you sort of save yourself is that you catch them quickly through good observability of your running system, right? You understand what's going on. Some of it is observability in the pipeline itself, but a lot of it is just the monitoring that happens at runtime. And we accept some failure. We know that sometimes there will be a problem, and it's okay because we're going to find that quickly and we'll fix it. And the overall we will have progressed much better. But the challenge is that you want to move fast and break things, but you can't get broken into. You can't. Security is one area where it's much harder to accept. It says, fine, I'll deploy stuff, and every now and then I'll get hacked. That's okay. And then that doesn't fly that way.
No.
You need to protect the system. So, I think that this is an area that's not entirely solved in security.
Not at all.
For us, what we focus on is indeed these open source components and their vulnerability. And when you talk about observability and visibility, you want to know what components are using, what's going into which system, and what do you know about them, and make some wise decisions. With every single customer, we have conversations around when do you break the build, when do you stop ship, and when do you let it go, because you don't want to stop, you want to continue. But sometimes, if it's a CVSS 10, like a super critical vulnerability where I can kind of blink and take over your server, you should stop. You shouldn't be allowing that to move on to production. But then, that's the sort of the black and white view, and then all these layers of gray happen before. It's tough. There is a world in security today that's called deception. That's all like post-hack that once again says, listen, you're going to get hacked. It's an inevitability.
Right.
So really the question is, how long is it going to take you to find out about it?
Yeah.
And to an extent, although that world has come from an almost desperate perspective, it actually has a lot in common with the world that says servers are going to go down. And what you want to do is you want to make sure that you have monitoring systems that catch that and find out about it as quickly as possible so you can do something about it, as opposed to fighting against the inevitability of it happening at some point.
It must be a fascinating time for you. I mean, there's this emerging conceptual framework around application development, around programming itself, where we've seen recent major security threats that have you question basic philosophies such as if this, then that, right? How far do you go down the branch before you've given up something that you don't even know you've given up?
Mm-hmm.
So like the attacker's already there and you don't even know it.
Yep.
Or there's somewhere else because you've given them a clue, right? And so we started to see more companies out there that are trying to think about how do you, let me not deal with that issue in particular, but there's a whole set of issues that you're starting to see emerge, right? And in particular, I'm starting to see kind of the emergence of almost behavioral-based security platforms, right? That are using the data from the resource itself to then help you guide you. So you essentially get a warning. No, you don't do that right now.
Right. And
I'm curious on your take on that. Because there's all these sets of challenges.
Yes, and I think so. There's been some walls or some boundaries between these worlds. So to an extent, tools like what you described are actually in some respects, they're old news in the world of security. There's the SOC, just like alongside the network operation control center, the security operation control center has evolved. And some companies, not that many, but the top security companies, like the companies that care most about security and can afford it, have SOCs and that evolve. And there's a whole industry called SIEM, which is a security incident event management, that consolidates information and looks at it and runs with it. And I think that world, many of the concepts of like I want to track what's going on and I want to feed it and have that drive my actions has evolved. I think what is changing is who is doing that work. So in a world that shipped software every 6 months or every 12 months, you can have your security team be trained on it every time there's a release and get updated and build some proficiency on it before the next release train comes along. And it's still the case where many people see a quarterly release as a triumph. And in fact, maybe even most people in this setup, and even then it starts to become a struggle. But when you release continuously, that just doesn't work. And suddenly the knowledge gaps and the evolutions of the application just, they don't scale. So I think one of the key challenges in the space, and I think also one of the reasons it's coming into this ops world and dev world, is because we have a growing need for this information, and maybe slightly different information, to speak the language of ops teams. For the NOC team, and then subsequently just the developer carrying a pager, would get the right information to guide the right actions and be actionable without having the same depth of expertise and sort of cycles to deal with it. As a developer, you need to do a ton of things. And one of them is to build secure software, but you really need your scaffolding. You really need tools that help you, and we need some concepts and some best practices. And I love that now there's some security talks in most developer and ops conferences. Some of them, like conferences like QCon, now have a security track for like 4 or 5 year conferences going, and just this evolution of awareness, and in turn the evolution of the tooling, which we're sort of happy to be a part of, but we're not the only ones, just evolving to try and speak security, or sort of make security speak the developer's language.
Right.
And indeed build on data.
So just bringing this conversation back full circle, then we started off talking about the dual popularity of serverless architectures and Kubernetes. We then talked about kind of the environment that we're in now, really the market conditions that we're facing. And you talked a lot about, kind of looking at kind of the holistic kind of view of, of security and kind of context of developers. How does that then speak to the dual popularity of serverless and Kubernetes in your view?
I think, so to an extent, serverless and Kubernetes, or kind of containers, are, in some respect, they're in the same continuum, where they still try to move some, increase some agility, move some problems, some concerns off the developer's hand, and be able to get to the point, which is infrastructure as code. The delta between containers and serverless, mostly sort of containers and or Kubernetes and serverless, oftentimes comes down to what do you want to control versus what which constraints are you willing to absorb.
Right.
If and that applies very much to security. If you're in the world of serverless, you still need to worry about security. There are other aspects of security, but there's no doubt that there is a whole layer of security concerns that that kind of get addressed for you because you've offloaded them to the platform, and you accept some constraints in the process. In containers, you kind of take on more of that responsibility, and in the process you get more control, but with great power comes great responsibility, right? Like you need to now be securing these entities.
Certainly do.
So I think both of them, I like the notion of like this being a dual nature, because in both of their cases they're empowering the developer.
Right.
They're moving the kind of concept, the old term of infrastructure, off some amorphous later down ops team or security team into the hands of the developers. And it's almost just like drawing the line of saying, hey, Mr. Developer, Mrs. Developer, what do you want? Like which level do you want to draw? Coming back a little bit to something I said before, which is one of my concerns is that in the process the world likes black and white, and they like saying that yes, we roll. We move all of this thing to the developer's hand, and therefore it is, serverless. It is infrastructureless. You don't need to worry about it. I expect some retro that happened here. I expect some understanding that the fact that we took off the physical aspect of needing to manage servers or VMs, or all the way to serverless, doesn't imply that we can shed some of the concepts of securing our infrastructure. And we just need to adapt those practices of securing infrastructure to work in an app world, right?
Mm-hmm.
To work in a developer world, versus lay them by the website and get hacked.
Well, Guy, this has been a really fun conversation. Thank you for taking the time, and congratulations on the growth of your company and the success of it. And this is such a topic of interest to us. And in terms of Kubernetes, in terms of serverless architectures, there's about 100 more questions I could ask. So we'll have to find another time and chat.
Yeah, thanks for having me. It's a blast, like
Thanks, Guy.
always.